Everyone, let's review about the bilging. For the bilging, we are working with the rectangular vessel in our course. So rectangular as a barge. So if this be our vessel and this will be current water line. What is the bilging? Bilging is if one of the compartments is, if this is your compartment and the compartment as a whole what will happen, the whole of this compartment will be filled by water, and that's what will happen. All the compartment will be filled by water. Initially, what we have initially, this was center of gravity, and here was our initial center of buoyancy. After we losing this compartment, the water plan area will be changed. Why? Because the vessel will be sink, and new water line will be here. Okay, this will be our new water line. New water line. As a result, while we lose this buoyancy of this compartment and vessel will be sink, we are going to while this compartment we're losing buoyancy of this compartment, our vessel will be sink, and this compartment will be added to our buoyancy. So as a result, the buoyancy, center of buoyancy will be changed, position of center of buoyancy, and center of buoyancy will be here. This will be new center of buoyancy. So our vessel is sink. What we want to find, we want to find this one, which is how much the vessel is sink. We call it parallel sinkage. And it's equal to how much volume we have lost volume over the area of water plan area intact. Water plan area. And why this formula came from? The water plan area, which is AW, if we times that one to parallel sinkage, or delta D, change of the draft, this one will be equal to this area. So how much volume we lost? This will be volume equal to this green, yellow one, and so this should be equal to lost volume. How much buoyancy you have lost, you have to regain it again. Why? Because the displacement hasn't changed. Displacement still is the same. So lost buoyancy should be equal to how much we are going to gain, because at the end our final displacement is equal to our buoyancy, while the final displacement does not change, thus final buoyancy also should not be changed. So this is how you're going to calculate the parallel sinkage. Okay, but let's see what will happen if the compartment is not at the center. If this is our vessel and so this is the initial waterline area. So if the compartment is going to bilge, is at the one end of the vessel. Okay, we are going to lose this compartment. Okay, first bring it here. Okay, this compartment, if we are going to lose, what will happen? The water plan area, our vessel will be sink, as we reviewed previously. This will be the water plan area. This was center of gravity. And here was our initial center of buoyancy. After bilging, center of buoyancy not only will shift upward, but only will shift to the side. Why? Because we are losing buoyancy from one side, and our new center of buoyancy will be somewhere here. This will be our new center of buoyancy. After our vessel to be stable, remember all the time center of buoyancy and center of gravity will be in the vertical line. This line will be the vertical. That means whole of the vessel will be rotated, and this will be not be our original water line or final the water line. Final water line will be something like as this one. If I'm exaggerating, it's not this much change. Final water line will be something like as this one. All the time remember the vessel will be inclined toward the lost compartment. If engine room is bilged, aft of the vessel will be sink more. If bow of the vessel or one of the cargo hold in the forward as you are losing, that compartment will be lost. The vessel will be inclined toward that one. You have to find and calculate how much the trim will be changed. So changing of the trim, what was the trim? Trim was change of the difference between forward and aft draft. How much was draft in the forward? This is forward draft and aft draft initially. After bilging, this will be our forward draft and this much will be the aft draft. Okay. How much the trim has changed or how much the difference has changed, you can calculate it. So you have this formula in your textbook. So changing the trim, change of trim will be can calculate as your vessel displacement. And remember, vessel displacement does not change because you haven't load or unload anything. Just water is just one of the compartment. You lost the buoyancy of that one. So it will be the displacement times BB1, BB prime, which is over MCTC. You should remember MCTC from his previous chapter is moment to create 1 centimeter change in the trim. Okay? You have MCTC from the hydrostatic data table. Okay? And this BB prime actually is this distance. Okay? So you can calculate how much your vessel will be changing the trim.